to have some people in the meeting. We will start at 3 o'clock. So, hello everyone, good afternoon. Let me turn my camera on. Thank you very much for coming here, being here today for this HEADSTART midterm event. Thank you all for this. Just for your knowledge, I will say it in a few slides, but this event will be recorded and will be made available. But this is when we get, I will explain it more further when we get to the rules of the event today. So let's start with the agenda today. Carlos, please, one slide. So what is HEADSTART? So we'll start with the basics. What is HEADSTART? Well, the HEADSTART project, it's a Horizon 2020 European Union funded project on the call ART01 2018. It's a research and innovation action, and it started the 1st of January of 2019. So we recently passed this barrier of the half of the project, and that's why also the reason that we have you today with us, so we can show you what we have been doing during these 18 first months of the project. The budget of 6 million euros, and we are 17 partners in the project. My name is Álvaro Rue. I'm project manager in HEADSTART, and I have also the pleasure to be the project coordinator of this project. You also have some information there. We will keep on reminding you all this data on how you can stay in touch with HEADSTART and be aware of all our news and events. Next slide, please, Carlos. So this is the HEADSTART consortium. Okay, it's 17 partners with a distribution around Europe. So we have different participants from many member states of Europe, and just wanted to give you some highlights of what are the statistics in terms of who we are. Within the consortium, we've got up to 7 research centers. We have 2 technical services for type approval. There are 3 Euro NCAP accredited laboratories. Within the consortium, we also have presence of industry with 4 OEMs and 2 tier 1s. And this consortium was built in a way that we wanted to bring together what was the expertise coming from testing, validation, and certification of connected automated driving around Europe, not just from European level projects, but also at member state. So, for example, we've got 3 coordinators of Horizon 2020 ART calls, but we have also participants within this consortium that are leading or are very important partners of the activities that are being done at national level. Carlos, could you please move to the next one? So just to give you an overview of the project, this is a midterm review, so it's also necessary to explain you how we are organized. And you will also see that with some parallelism of what we will explain today. In the project, we've been working on Work Package 1, led by Vedecom on use case and requirements. IKA was the leader of Work Package 2, which was in charge of the definition of the methodology. You will see more today on this. We are currently in Work Package 3, Architecture, Environment, and Tools, that is led by Virtual Vehicle. And this will lead to the demonstration Work Package 4, which is led by TNO. We also have Work Package 5, led by Ertico, which is in charge of the communication with the expert community surrounding connected automated driving testing. And ICCS is giving us their leading us in terms of communication and dissemination. From the coordination, as I said, HEADSTART is taking this role within the project. Next slide, please. So what is the project concept itself? Well, I don't want to stay too much in this slide. I prefer to go to the next one. But we are looking at all these different points of view. So we are going left to right. We are following the selection of different scenarios, what would be allocation of these scenarios, how do you test it in different test methods, how will you evaluate these results, and then what would be the output. So in generic terms, and I can explain it better in the next slide, Carlos, please. It's that HEADSTART will define testing and validation procedures of connected automated driving functions. And here we are also including what we call in HEADSTART key enabling technologies. In the particular case of this project, these key enabling technologies are communications, cybersecurity, and positioning. 3 of them important enablers of what is connected automated driving. We're also doing this by cross-linking all different test instances, test methods, as for example, simulation, proving ground, and real-world field tests. But why are we doing this? In order to validate safety and security performance according to the needs of what we have defined as the key user groups, key target groups of the results of the project. And for us, there are 3 of them. First of all, technology developers. So this is something that could, it's in industry, OEMs, tier 1s, people that are implementing the technology. But we also have consumer testing, which, for example, for those that you are not familiar with the term, would be the Euro NCAP protocols or NCAP protocols around the world. And finally, what would be type approval. So we're also targeting within this testing and validation procedures, what would be homologation, type approval of vehicles. And we are doing this in 5 different stages. Oops, Carlos, could you go back? Yes, 5 different stages. First of all, 1, identification. So, and you will see today, we have really thoroughly looked about what's going on in the world. To do what? To find what is the potential harmonization. So what are the different activities that are being done worldwide, and what are the commonalities? What are the differences? Where are the gaps? This helps us to get us to our 3rd stage within the project, which is definition and development. So here we get all the state of the art, all the harmonization and gaps, and we start defining, developing, and implementing what would be these procedures for the assessment of automated driving, which will be finally be demonstrated in the real world, in real tests, in proving grounds or by simulation. And this will be part of the activities that we will do in our 2nd half of the project. We also have a 5th step, reach consensus. And what we do here is not that it's at the end, but it's a transversal activity in which we are creating an expert network, in which we are engaging with different dialogues with the community, with the different stakeholders for 3 objectives: providing, showing where our progress, getting the feedback, and also steering where we should go. So if we go to the next slide, I've got a nice video of what is the HEADSTART project.
The EU-funded H2020 HEADSTART project aims to define testing and validation procedures of connected and automated driving functions, including key technologies such as communications, cybersecurity, and positioning. The testing will take place in both real-world and simulation environments, virtual testing, XIL-based testing, proving ground testing, and field test. Considering CAD stakeholders' real needs, we'll harmonize the existing methodologies, procedures, and tools for testing, validation, and certification. Within the lifetime of the project, an experts network will be established to actively contribute and promote adoption of the project results. HEADSTART will establish 3 use cases to demonstrate the developed methodologies, procedures, and tools. HEADSTART is expected to set the basis for a harmonized European solution for testing and validation of automated vehicles, ensuring safe and efficient mixed traffic flows.
Okay, thank you very much. Next slide, please, Carlos. Just an information or media, social media, where you can get more information. But of course, you can do this after this nice event that we are going to have now, in which we are going to tell you firsthand what have been our results, our activities, and our results during this first period of the project, this first 18 months. We move on to the next slide, please. Let's start. Yeah, this is the agenda for today. We've already had the introduction of the project. Our first speaker will be Jean-Baptiste Collet from BDCOM, and he will explain different initiatives, worldwide initiatives that are dealing with the scenario-based validation. We will have also an overview of the HEADSTART methodology, how we have reached this methodology, this harmonization in the methodology. This will be followed by how do we integrate these key enabling technologies that I introduced a few seconds with the HEADSTART methodology, how they can be included. At almost 4:15, we will have a small break so we can refresh ourselves, and we will come back to see how we are moving from this methodology to the procedure. So yeah, from what to how are we going to make this validation? And then we will also show you a bit more in detail what are going to be the HEADSTART use cases. A small overview of how you can join us, how you can support, and you can be actively cooperating with HEADSTART project will be presented by Stefan Dreher, and we will finally give you an overview of what are going to be our next steps for the second half of the project, which will end the 31st of December of 2021. Next slide, please, Carlos. Some rules, some things you should know regarding this midterm event. This webinar is being recorded, so everything that you will hear today will be available on the HEADSTART website, which I always invite you to visit. We also have set up a system to get your questions for today. So it's the slido.com. I don't know if you're familiar, it's very easy. Just go with your laptop, go with your mobile phone, write www.slido.com, and when it asks you for this hashtag, please just include hashtag HEADSTART, and then you will see that you can directly write your questions to us, which will be answered during the session. We have some moderators behind. If the questions, because of time limitations, cannot be answered, we will take them with us and we will answer them. Do not wait until the end. If you have some questions, if you think about some questions you would like to have a direct answer, just write it down in the system and at any moment during the presentation. And just one thing, we are doing this event on the GoToMeeting platform, but please do not use the chat from the GoToMeeting. Please use the Slido. It is much easier for you, for us, and we can have, you will have more flexibility, you will see. And next slide, Carlos. Then we start with our first speaker, Jean-Baptiste Collet from BDCOM. Please, the floor is yours.
Thank you, Alvaro. Hello, everyone. So my name is Jean-Baptiste Collet. I work for BDCOM Institute in France. And today I'm going to talk about the very first step of the project, the scenario-based validation for CA, for connected automated driving. So mainly the state of the art on initiatives and different projects. Next slide, please. So this work.
Hi, Jean-Baptiste. We're having some trouble hearing you.
First work package. Of the state of the art.
Jean-Baptiste, we cannot hear you. You have some connection issues.
Out in the
well, things that happen with connectivity these days. Jean-Baptiste, we cannot hear you. I don't know if you hear us. So it looks like a bit bidirectional. Hello?
So this point will also be discussed a little bit later in the event. Next slide, please. So the first point that is of interest today is the state-of-the-art, state of innovation and gap analysis that was led by IKA. The objective of this work was to provide a detailed analysis on the existing state-of-the-art, on different validation and testing methodology for connected and automated driving, and finally identify the gaps based on the results that we had. So there were seven topics of interest for this state-of-the-art. So the first one was terminology and taxonomy to build a glossary of terms. Then we had research on scenario concepts, research projects, initiatives, tools for safety assurance, legislation, and finally methodology. So all these topics were connected to, of course, the safety assurance for connected and automated driving, because the automated driving topic is very broad. So we tried to narrow down on this topic. Next slide, please. So the first topic was the terminology and taxonomy. In order to build a glossary of terms, we did research of the different terms that were used in different CAD projects and different standards as well. The goal for us was to select the terms that were relevant to the scope of HEADSTART, that would be representative of this term, and that was clear and concise. Regarding the taxonomy, we checked the different type of taxonomy for automation levels, and most projects were following the SAE J3016 taxonomy, but we also find some other models that existed, such as the one from BAST and NHTSA. Next slide, please. So the second point of interest was the scenario concept. So the goal was to define how the scenarios are defined in different projects. So we did some research in some research projects on these topics. So the main projects that were looked into were the Pegasus project in Germany, the MOVE project in France. We had TNO Streetwise from the Netherlands. We also had the L3 pilot, which is quite famous European project. And finally, we also looked into a Japanese project called Sakura. The research project that were looked into in this state-of-the-art, the goal was to find a different project that could be of interest for HEADSTART, maybe for future collaboration. So 38 projects were identified. So the goal for us was to find some projects that were involved either in one of the key enabling technologies, so V2X communication, cybersecurity, or positioning, but also more broadly on connected and automated driving testing, so test definition and testing activities. In the next slide, you can have an overview of all the different projects that were looked into in the state-of-the-art. And yeah, so there was quite a lot. In the next slide, you have the next topic on initiatives, were pretty much the same as the research project. We looked into different initiatives that exist worldwide, and we tried to find some of those initiatives that could be relevant for the testing of connected automated driving. So we found different manufacturers association, public authorities, some initiatives that are linked to key enabling technologies, some to consumer testing. So you have your NCAP here, but there's also all the different NCAP, and a lot of other initiatives linked to testing. In the next slide, you can have an overview of the location of those initiatives. So you can see that a lot of them come from European countries. We also have some in the US, Australia, New Zealand, Singapore, Japan, and some of them that are not in a precise location, but worldwide initiatives. In the next slide, the goal was to list the main tools that would be relevant for HEADSTART for the next steps of the project. So we listed the tools in 4 categories: the annotation tools for video annotation, for example, or annotation for 3D content, the recording tools, the simulation tools, and the physical testing tools such as dummies and the software to control the dummies. And the 2 last points of this state of the art were the legislation and the methodology. So in the legislation, a lot of different legal texts have been looked into in order to find what is already existing in the testing for automated driving. So we had a source from European, but also worldwide legislation, and also some national legislation, standards, and guidelines. Regarding the methodology, we found already existing methodology for safety assurance of connected automated functions. And here again, we also looked more specifically into several projects. So we have again F3 Pilot, Pegasus, Move, Streetwise, and Sakura. So the basic methodology would be, in those cases, much more detailed in the deliverable if you look at it. But the basic methodology is first from real-world data. You collect the data from the cars, then you process them and extract the scenarios that you store in a database, and finally you evaluate from those scenarios and you do your testing. So that brings us to our second point today that I will present, which is the second activity that we did in the work package 1, is the identification of the stakeholder needs. The goal of this activity was to identify the needs on methodology, procedures, tools, standards from the viewpoints of different stakeholders that are involved in connected automated driving. So in the little diagram down there, you can see that you have on your left the different types of topics that we were asking the stakeholders about. So we were asking about use cases and scenarios, safety assessment and safety case, testing, certification and type approval, consumer testing, and finally the testing goal for key enabling technologies. On the right, you can see that the different type of stakeholder that we contacted were the OEMs, the automotive suppliers, public authorities or policymakers, consumer organization, and research institute and universities. The way we carried out those interviews, or we collect those needs, were through either face-to-face or phone interviews. We also used targeted survey, so we sent a survey to specific people via email, and we also did open online survey, so anyone could give their opinion on the different topics. In the next slide, you can see that these are the general results of our interviews. So we interviewed a lot of people from research institute, you can see, but we also have some good interviews from OEMs, automotive suppliers, and public authorities. And we also had some from consumer organization and universities. We also have some online surveys that were answered on all of those topics. In the next slide, then I'll go topic by topic to give you a little overview of the results that we had after those interviews. So regarding the use case and scenarios, the goal was to identify which were the priority use case for those stakeholders in order to help us align with the selection of use case later in the project. So here you can see that the main use case that were prioritized by the stakeholders were highway pilots, traffic jam chauffeur, valet parking, urban automated shuttle, and truck platooning. In the next slide, we have the topic of safety assessment and safety case. Here we identified the main risk to the connected automated driving functions and how to improve the safety. So we asked open-ended question on the opinion of different stakeholders on what would be the main risk. So the risk identified would be the misuse of the system. So for example, using the automated function outside of the ODD, so activating your automated driving in the urban environment when you're supposed to use it on highway, for example. You also have the risk of encountering unknown scenarios. You have, of course, the software updates and bugs that can happen, the criminal activities and cyber attack, and finally the loss of positioning or connectivity that could also represent a high risk for the function. Then we talked a little bit about the different approach to ensure safety. So a common agreement would be that the scenario-based approach is the most commonly used, and that is probably the one that would be interesting for HEADSTART. That the validation should combine different test instances, for example, simulation, physical testing on test track, or collecting data on open road testing, for example. We also had some tools for safety that were discussed, such as the ISO standard 26262. And there was also the fact that there was no precise legislation for the high-level functions of 3, 4, 5, for example. In this slide, you can see that the testing activities that would be interesting for those stakeholders were presented. So most testing that at the time were taking place were on level 2 and 3, but we're about to improve to level 3 and plus. So this is from last year, so it's probably evolved since. And that the testing organization were focusing on performance and validation tests. So there was no fixed methodology that were accepted apart from some protocols such as the one from Euro NCAP on consumer testing. There was a common agreement that there was a need for common methodology, and that is one of the objectives of the HEADSTART project. In the next slide, we also interviewed some people for type approval. So what would be the needs for testing in regards to type approval? So we had a lot of different interviews, and one example that we have is that there was quite often the 3-pillar concept from OICA was presented, was discussed. So the 3 pillars would be audit assessment, physical certification test, and real-world test drive. So a combination of those 3 pillars. In the next slide, we also looked into consumer testing. So as Alvaro said earlier, the consumer testing organizations are one of the final target users of the HEADSTART methodology. So what we found is that those consumer testing focus mainly on the functions that are already available on the market. So at the time it was only level 2. And that the goal for the consumer associations was a little bit different than for type approval, for example, because they focus mainly on safety benefits rather than safety assurance. So here on the diagram, you can see that safety assurance would be how many lives could be saved and how many accidents could be avoided, whereas safety benefit is the function able to perform as expected without adding any risk to the driver or other people on the road. In the next slide, you can see that the main source for these interview and a lot of consumer testing needs were collected from the Euro NCAP 2025 roadmap with different features that would be tested in the next years. So we have some of them here. Driver monitoring, automatic emergency steering, etc., etc. We also have some other features that could be interesting for HEADSTART, such as cyber security. And in the next slide, finally, we have the needs on testing key enabling technologies. So the different stakeholders were asked about which one of the aspects where which use case would be interesting for the key enabling technologies. And you can see here that the main use case that were interesting for cybersecurity, V2X communication, and positioning were highway pilot again, automated truck platooning, traffic jam chauffeur, and the automated shuttle. So that's about it for my presentation. Thank you for listening, and I will check the Slido to see if there is any question. So we have a question: what research project were including the state of the art? So we have a lot of. If you go back to the, I'm sorry, Carlos. If you go back to the slide 6 of my presentation, no, like the point 3, yes, on research project. A little bit earlier, please. Earlier, on the point 1, yeah. This one. Yes, thank you. So you can see a lot of different research projects that are pretty much from all over Europe. So Autopilot, Move, Pegasus, R3 Pilot, Enable S3. You will be able to find those details, our analysis in detail in the deliverable. The next question, I think, was also yeah, where can I find the results of the state of the art? You can find this via our website. All the work package 1 deliverables are available on our website. You just go to HEADSTART. I'm not exactly sure. Let me find the address. HEADSTART-project.eu, and there you can find in the results to date, you can find the deliverables. We have a question from Richard. Safety assurance benefit. It looks as if the explanations, how many lives the function is able to perform, are mixed up. Shouldn't that be the other way around? Maybe. I'll look into it. Maybe I made a typo. Any other question? So if that's all, I'll leave the mic to the next presenter.
Thank you very much, Jean-Baptiste.
Thank you all.
Okay, well, hello, my name is Nicholas Wagner. I am group leader of simulation in the Institute of Automotive Engineering in Aachen, IKA, and we were the work package leader of work package 2, the HEADSTART methodology. Okay, next slide, please. And show the agenda. Okay, so we're starting with a short introduction, then the motivation for our methodology, and then I go more into detail on the overall methodology, which we developed in HEADSTART, and then later on in the next presentation, they want detail on the pro. And process. So the webinar is being recorded. Slides and recording will be shared and published on the website. If you have questions, go to slido.com with the event code displayed here. Yeah, and don't ask the questions in the GoToMeeting chat, as Alvaro said in the beginning. Yeah, just ask them via Slido. Okay, next slide, please. So, yes. So what's the goal of this meeting? We would like to get some external feedback from the experts, from you, on the methodology. Of course, questions are more than welcome, but also some feedback on the methodology, because we want to create a harmonized approach here in HEADSTART. We want to harmonize existing approaches, and therefore we are heavily reliant on feedback from the expert from the international consortium. So the feedback will be integrated maybe as a refinement of the methodology, maybe in the process, which we're working right now on. This depends on the feedback we are getting. Okay, next slide, please. So where does the HEADSTART methodology come from? Next slide, please. Okay. We did a state-of-the-art analysis of international and national projects, which Jean-Baptiste just introduced. And thereby we try to harmonize present and past projects within the EU, but also beyond these borders to the US, to Japan. We're trying to talk to these people and to create a harmonized method here. We try to utilize common databases to analyze data and to test then the selected relevant scenarios. But this is on the next slide as well. Okay, why do we need scenario-based safety assurance? So safety assurance by test drives, we could just drive on the open road. Simple calculations show that that we would need to drive up to billions of kilometers, which is just not feasible, especially if you have to do it for each update your driving function gets. If you find a smaller bug in the driving function and you have to update it, then you would have to drive these billions of kilometers again. And then safety assurance by expert knowledge. As far as we know, there's no evaluation methodology available for automated driving for level 3+, so it's not available. Next slide, please. So therefore, how can such a methodology look like? And we would like to show you now the basic concept of a scenario-based safety assurance, which nearly all the projects we analyzed have in common. So we start with input data. We are looking into field data, area data, infrastructure data, accident data, simulator data, whatever. These are just some examples here on the left-hand side. And then we integrate this data by database mechanics in a database, store it there as scenarios. So we extract scenarios from the real world. Then in the next step, we need to generate a complete scenario space, which is the point 3, coming into the database, so that we can be sure that the database is complete, or at least we know how complete the database is. And then we are just testing these relevant scenarios in the 4th step. We generate the output, use the test concept, and test it on the 3 different pillars: the simulation, X in the loop, and on the proving ground. And then finally, we use the results from the testing in the evaluation, and we can say if the driving function is safe or not, or how safe it is. Okay, so on the next slides, we would like to show you a more detailed picture of the HEADSTART methodology. It basically follows the picture we just showed before. So we're once again starting with the different data sources, as said before. And then we have the database and mechanics. So we have the input data. We need some pre-processing. Then we extract the scenarios based on the specific scenario concept, which is in this database. And we have some post-processing and the extraction of the parameters. So we need to parameterize our scenarios and save it in the scenario database. And then for the completeness, we have some injected scenarios. Of course, this can be based on expert knowledge. That we say some scenarios are very important to be tested and they need to be stored in the database based on some expert knowledge and also on the completeness. And the output of the databases is, of course, the logical scenarios and the parameter distributions and the exposure, so that we know how often the scenario is there, and that's some input we can use to select the relevant scenarios. So this whole database and mechanics part, we just described it, what are the basic steps, and not wanted to go too much into detail on this part, because we want to utilize existing databases in HEADSTART. HEADSTART is not big enough to build up another database, and there are quite some databases like the Pegasus database, like the MOSA database, or the TNO Streetwise database, and many more, following VMP methods database and so on, which are very large projects creating databases. So we just want to utilize these databases and harmonize the general approach. Then in the selection of the relevant scenarios and the parameter variation, we query based on the driving function and based on the use case. So taking into account the operational design domain, the minimum risk maneuver, the functional requirements, and so on, taking all this into account, we query for specific data, for specific scenarios from the scenario database, and we get the logical scenarios, parameter distribution, and the exposure into our parameter variation, and we vary these the parameters within the ranges from the parameter distribution, and we get out some concrete scenarios which can be tested. And then the next step, we enhance the scenarios by the 3 key enabling technologies which were already shortly mentioned in the beginning, and which will be explained in more detail later on. So then with this concrete scenario to be tested with the key enabling technologies already in there, and we need to allocate the scenario to the different test instances. Of course, we try to allocate as much as possible to the virtual simulation because it's highly efficient and we can test a lot of scenarios within the simulation. But there might be some scenarios, or there are some scenarios which need to be tested on the proving ground or in XIL-based testing environment. And this is based on the capabilities and the requirements from the specific test environment. So a proving ground can have some capabilities, and we try to match these capabilities to the requirements of the specific scenario. And then we have some sort of special path, which is the field testing, because we cannot really stage a scenario on the field, which is quite logical. In the field, something just happens. So we can just look into the existing infrastructure and then create scenarios based on this infrastructure, or see if we can find scenarios based on this infrastructure, and then we can just see how what scenarios are there in the field, especially on the CAD layer. So for communication, for example, we can look specifically into the communication part. Okay, and then finally we have the evaluation. Of course, this is based on the pass-fail criteria, which is of course also based on the driving function and the use case, the pass-fail criteria and the human capabilities, so that we can compare the result of the driving function to the human capabilities, and thereby have a feedback loop, of course, to the selection of the relevant scenarios, so that we can test more on specific scenarios which the evaluation tells us, and of course we can have a feedback loop into the database from the evaluation if that's necessary. And finally, we have the results telling us then how safe the driving function is. Okay, next slide, please. Okay, and then that will be mentioned in more detail later, but we identified that especially cybersecurity assessment is somehow quite specific and cannot be just an enhancement of the scenario. So it can be a small enhancement of the scenario, but the real cybersecurity assessment needs to be done separately, and therefore it's a special box here which goes into the evaluation. But I don't want to go into detail here. Okay, now I would like to first talk about the selection of relevant scenarios and stochastic variation, and then in the next step on the allocation of the scenarios. So for the selection of the relevant scenarios, first I would like to introduce the layer model, the 6-layer model, which is originally from Pegasus, and which is used here in the HEADSTART project. So we have the layer 1 to 6. Layer 1 is the road layer, including the road geometry and the basic road information. Then we have layer 2, which is road furniture and routes. So we have the speed signs, we have trees by the road, we have static objects. This is all in layer 2. Then we have layer 3 with temporal modifications and events like construction sites, barks, traffic cones, or even a fallen tree. Then in layer 4 we have moving objects with vehicles, pedestrians, a cyclist. All of this is then in layer 4 with the moving objects. And on layer 5 we have the environmental conditions, like the light, the sun, but also icy weather, snow, heavy rain, for example, or fog. And then layer 6 is quite new, so we can or projects show like Pegasus, like Streetwise or Move. They all show that they quite include layer 1 to 5 quite well, but layer 6 is somehow a new thing, which is the digital information, the V2X information, the digital map data, and so on. And this is heavily reflected with the key enabling technologies in HEADSTART, especially the communication key enabling technology, which is on layer 6. Okay, next slide, please. And then just for a short overview, so we have this scenario database. We query based on the driving function for the relevant scenarios for that specific driving function. Of course, especially taking the operational design domain into account, but also other information. And then we get some relevant scenarios as logical scenarios with their specific parameter range. This is just some example here, so it's not. It's just an example on the right hand side. And then we use parameter variation and then combine it to a concrete scenario, which is then rolled out into the testing part. Next slide, please. Okay, now the next slide, please. Allocation of scenarios now. So we now have the concrete scenarios, and as I said before, each test instance has its advantages and restrictions, its capabilities, basically. And we would like to test everything on the virtual testing in the simulation because it's highly efficient and it's fast and not very costly. But some scenarios might be necessary to be tested on the proving ground or in a hill or a mill or whatever. So X in the loop testing. So our objective is to define how to indicate the selected concrete scenarios to each test method and to find the best fit. Next slide, please. So we looked into the definition for the capabilities of sensor, environment, and vehicle dynamic model, or real vehicle for proving ground, of course, and vehicle in the loop testing. And then we identified which degree of realism is necessary for each of the the different pillars here, and thereby we can select if we can allocate it purely to the virtual simulation or to the proving ground or something in between, so that we can need to select a real vehicle driving on the proving ground with a co-simulation as a vehicle in the loop approach for the environment. Okay, next slide, please. Okay, finally, something on the testing from the methodology part. So our scenario execution, as I said, there are the different pillars for testing, and we would like to use or promote unified interfaces like the Open Simulation Interface, OSI, and functional mockup interfaces for co-simulation for the simulation itself, and then the open standards, which is HEADSTART heavily building on the open scenario, the open drive, and the open CRG. These are open standards currently developed by the ASAM consortium, and they are heavily in use internationally, and we would like to promote that in HEADSTART as well, to build on the open scenario and open drive and open CRG for the scenario exchange, to have the scenario execution arbitrary from the specific project or manufacturer. Okay, next slide, please. And then the skill-based testing, just a short overview from the methodology point of view again. So we have as input the open scenario and the open drive. Of course, the open drive is for the initial setup within the simulation or the proving ground or anything in between. And then we have the open scenario, and we can select for each part of the scenario, or the driver or the traffic, the environment, the possible pedestrian, anything else. This is just an example. The degree of realism which is needed, and then it is then rolled out into the test execution by a co-simulation between the simulation and the proving ground, and therefore we can test with that needed degree of realism, but still efficiently as possible. Okay, next slide, please. Okay, in summary, the HEADSTART methodology is a living process. As I said in the beginning, we need expert input to refine the methodology, to refine the process, which is currently developed based on the methodology, and it's high effort for safety assurance on national and international levels. So we are looking in a lot of projects, but of course, the experts, you have more insights in your specific into your specific project, and therefore we would like to have more feedback. HEADSTART tries to harmonize the different projects and international initiatives. So the international cooperation is key to safety assurance for us, and I think for everyone. Okay. Next slide. So thank you, and I'm looking forward to your questions in Slido, not in GoTo. Okay, which one was the first one? Is it open for other databases? I'm starting at the bottom. So is it open for other databases? I think you mean that if HEADSTART is open for other databases, of course, yes, it is. If you have something which fits the basic methodology and which follows a scenario-based approach, we are happy to talk to these database people, and yeah, we would like to be as open for other databases as possible. Regarding the databases, to which ones are you going to connect? Are there any differences between them? We are planning to connect to the Pegasus database, to the TNO Streetwise database, and to the Move database currently. So there, this is basically planned right now. They are all following the same basic methodology we showed, so that we can include them. Of course, they have differences, especially regarding the scenarios, regarding internal methods and mechanics. But we are planning to connect to all 3 databases and use scenarios as a demonstration in HEADSTART. Yeah. Are human factors included in the methodology? They are included in the methodology, but we are not focusing on them in HEADSTART. They are included. If you go to the slide of the methodology. Excuse me. Yeah. Okay. Yeah, this one is fine, I think. So, so we have the human capabilities down there at the evaluation. So we are looking into human factors here, especially on the human capabilities part in the methodology, but we are not focusing on it in HEADSTART. And we, yeah, it's not possible in HEADSTART to go further into details regarding the human capabilities, because there would be heavy simulator studies necessary and so on. So we have that in mind in the methodology, but we cannot go into detail here. Okay, can you show the Slido again? Okay. And the last question was, how important do you think is the international harmonization? Yeah, as I said in the as I said before, the international harmonization is very important to us. There are a lot of different approaches. Of course, they differ somehow, but the basic idea is often or nearly always the same. So we can build up 1,000 databases with some small data portions, but that wouldn't bring us anywhere. So we think the international harmonization is one of the most important things, and it's a key aspect of HEADSTART. Okay. So if there are no more questions, I would like to give over to the next speaker, and thank you for following.
Hello, good afternoon. This is Jack van der Sluis. So this session will consider the key enabling technologies, positioning, communication, V2X, and cyber security, and how to integrate them in the assessment methodology we use in HEADSTART. I prepared this meeting together with Andrea and Joachim. The presentation will take about 20 minutes, and the other people will also join as moderator for taking questions. So next slide, please. Yes, so this should already be familiar. Please raise your questions during the meeting using Slido. Next slide, please. So we have identified 3 key enabling technologies. They are considered main drivers for connected automated driving at current time and in future times. So they are relevant for automated driving and also in relation of scenario-based assessment we do in HEADSTART. So we have positioning for automated driving functions, really looking into the high definition positioning using satellite communication. Satellite positioning, sorry, we have V2X communications, which enable the vehicle to extend beyond their sensor rate and really get external information in. That can be done with different kinds of technologies, ad hoc wireless communications, cellular communications, V2X extensions to connected technologies, supporting cooperative applications. The last one mentioned here is cybersecurity, which is essential for really protecting the different safety functions also related to positioning and communication, to identify vulnerabilities and really to have a real-life secure deployment. Yes, next slide, please. So the key enabling technologies are an integral part of HEADSTART. We already saw that also in the previous sessions, where they are related to all the different work packages, task activities, and also different workshops, for instance, with expert group meetings we have organized. If you look at these different key enabling technologies, we look at them to enhance current automated driving functions, and in general to improve the robustness of the automated driving functions. So in the project, we focus on the 3 use cases: highway pilot, truck platooning, and for instance, truck platooning linked to the ensemble project, and traffic jam solver. And there will also be a dedicated use case session later as part of the program. Next slide, please. So just to stress out, when we start using these positioning technologies and communication technologies, when you are relying on the external data, there should always be a level of trust to that external data. And again, that is why we also identify cybersecurity as a key enabling technology, where the information trust is crucial in really the applicability of the external data. It's also for preventing security attacks. And first of all, you have to detect these attacks, and then you can take countermeasures. I think if you look at the project itself, we slightly take a different approach for integrating the different technologies. I think for positioning and communication, we use a quite similar approach, because we can consider it like additional functionalities to the automated driving system. But cybersecurity is a bit more an integral need for the automated driving function. Next slide. Yes, thank you. This slide, there's a lot of information in the slide, but it's just to highlight and illustrate it as an example how we are using these new information channels, where you have V2X communication, GPS positioning, for instance, also introducing new failure possibilities, which should be monitored and validated. We identified an additional set of parameters which need to be extended into the scenario-based assessment. And the importance here also is that there are also a lot of cross dependencies between these parameters. For instance, taking time synchronization, that is related to positioning, related to communication, very important. So there are a lot of dependencies in that sense. Yes, next slide, please. Well, here there is an overview of the different building blocks of the HEADSTART approach. And what you can clearly see here, I've highlighted some of the items related to the key enabling technologies, where you see that at multiple levels they are impacting, and we need to harmonize really the key enabling technology extensions and integrations in HEADSTART. If you look at the extensions of scenario parameters and future testing of the scenarios, we put the focus on virtual testing, the XIL-based testing, the proving ground testing, and the field testing. And in that sense, we are trying to achieve a common methodology for the CAD integration. And the next slides will go into a bit more detail per CAD. For the different testing categories we have. So this is an example, a high-level example on how we can integrate positioning into the different testing methods we have in HEADSTART. So for the virtual testing, for instance, you can introduce some variations in positioning parameters, where we can still start from existing scenario databases. For XIL-based testing, addressed in number 2, it is possible to create simulated signals or emulate signals depending on the hardware and software available in these setups. And then we can make the connection to the proving ground, where we can compare driving functions or look at improvements in positioning performance. Looking at the proving ground, it's also a way to validate, to be able to validate in a controlled environment. And looking at the last one, the field testing, that is really the part where you can also have some unpredictable environment. So that will also help really, again, for extracting profiles for vehicle on the test, and that is closing the loop again back to the virtual testing, where you can extend the scenarios where you include positioning inputs and also anomalies. Okay, next slide, please. So this is just an overview of some of the challenges we see for positioning. So there are categories like system and environment, and we also divide it in methodology, testing, and assessment. What you see here is really some of the challenges we need to take into account when developing testing methodology. For instance, an example is the possibility to extract GNS as position and associated error from vehicles on the test. And another thing is also the availability of having a minimum set of information needed to test to fully test the vehicles. Next slide, please. So again, the same slide for communication, looking at how do we integrate it in the different kind of testing we have. For instance, we consider communication as a sensor, for instance, in virtual testing, where we can have perhaps a very simple communication model, or we can also have a very complex model using all kinds of physical sensor models or probabilistic models. An example of, for instance, having a simple model is really where you can do some logical testing of V2X message exchange when, for instance, a platooning vehicle wants to join an existing platoon. Then it's quite easy to somehow do a logical testing where you ask a platooning request and you get some kind of reply or acknowledgement on that. Hardware and software in the loop testing, also these kind of xill-based setups can differ very much on software and on hardware you have available in the setup, and also on what do you want to test in that setup. I think one important capability is also to enable relevant V2X events in that kind of setup. For instance, introducing failure modes, communication failure modes while platooning. For the proving grounds, again, this is more a controlled environment. But for instance, are there any capabilities in supporting smart infrastructure, I2V communications? Are there any environmental elements available which disrupt communication? And for the field testing, there you can also expect some uncontrolled dependencies in relation with the environment, impacting the V2X communications, other traffic, other cooperative vehicles. And in that sense, also here we are trying to close the loop, where we have the creation of extended scenarios, including V2X messages contributing to existing databases, and also the possibility to validate or improve the models used in virtual testing and hardware in the loop testing. Next slide, please. So again, short overview of some of the challenges identified for communication. So, of course, we are not developing the technology ourselves. it's of course in the context of defining a testing methodology. Yeah, for just to highlight some examples for challenges for communications, and like there can be limits for the I2V capabilities available at proving grounds, local proving grounds. The environment itself can have some blocked coverage, or perhaps unwanted interference affecting the communications. Limited availability of 5G networks could also hinder real-life validation, as just to highlight some examples. Then next slide, please. So for the cybersecurity integration, the mapping on the virtual testing and cell-based and proving ground and field testing is a bit different. For instance, mapping the identified parameters. It's more about mapping that and selecting it to security requirements we want to test. And depending on that, you can prepare different scripts and execute cybersecurity testing, for instance, with penetration testing, functional and interface testing, fuzzy testing, for instance. And also the performed cybersecurity testing itself is leading back again to more the evaluation part of the cybersecurity methods used. A bit more detailed of this is available in the next slide. I think the main takeaway at this slide is that it's really important to perform all these cybersecurity assessment activities during the entire life cycle, and also that there should be a certain cybersecurity level of assurance in relation with the safety validation. And for the cybersecurity assessment, the approach we are using, so that are all the sub-bullets below, that is also, this procedure is also in line with the common criteria standard. So that is like what they have been doing already a long time in more the IT-related security. And we are using the same approach in our cybersecurity assessment. Next slide, please. Again, a similar slide for the challenges for cybersecurity. I think good to mention here is that in the context of the cyber attacks, we also put the focus on validation of the robustness of the other CAD, so of positioning, for instance, GNSS solutions used, and also for the V2X communication channels we want to use, because these are exactly two new input streams, also very relevant for cyber attacks. And another challenge for cybersecurity would also be integration of framework tools in the scenario-based assessment we want to do in HEADSTART, and also cybersecurity testing itself in automotive engineering is a relative new topic. So standards are available, but also a lot are ongoing activities, and that it's also a novel experience to really apply it in testing. Next slide, please. So to wrap up the presentation itself, there is a slide used as an example, the truck platooning use case. It's a selected use case for the project, and it's also linked with the ensemble project. Truck platooning is a very useful use case because we have V2V communication as part of the truck platooning application, where it's really also a safety related function, because the trucks are driving very close together, enabled by this communication. So in that sense, the technology is very enabling for truck platooning. But yeah, the same is also true for communication, where you need some accurate positioning information to be able to platoon. And yeah, again, also for cybersecurity, where you want to trust that information and you want to protect the system. If you look at communication and applying it in platooning, it's really important that we can extend scenarios with relevant V2V events, and also extend the tooling we have available, or tool chain, to enable these V2X events. So in the slide you also see some illustrations of virtual testing, XIL-based testing applied to truck platooning, where you can also test the different scenarios and introduce, for instance, communication failures, delay in communications, message loss, etc. For cybersecurity, it's really important to have some integration, implementation of the security assurance framework, and really validate the cybersecurity as we want to apply it in HEADSTART. And for positioning, where you can have data fusion with several sensors and positioning functionalities, and how is it maintaining the truck platoon information, and how reliable is the positioning solution, and how well can we do the different testing of it, considering virtual and XIL-based environment, and proving ground, and real life testing. So in that sense, truck platooning is a good example to validate all the 3 cats. But again, later on, we will have a dedicated session related to the use cases. Okay, next slide, please. So thank you for your attention. So we can now take some questions. I think Joachim and Andrea will also join for taking some of the questions.
Hello, Jaco. Thank you. Hello,
Yes.
thank you for the presentation.
Thank you for joining. Yeah, let me take the first question regarding communication. I was speaking about at CG5 cellular V2X. So yeah, we are talking in that sense about any kind of technology available. So yeah, in that sense, we are communication technology agnostic. So we are speaking about any technology supporting V2X communication, especially in the sense of cooperative technology related to connected automated driving. So it could be at CG5 communication where it's wireless based. It can be cellular based like LTE V2X. Cellular V2X from future 5G deployments, connected services, at least as they are relevant for automated driving functions. So I think that clears that question. And another question is, sorry, it disappeared. Okay, so the second question is related to cybersecurity.
So regarding key-enabled technology, why has fewer parameters compared to position and communication? Well, cybersecurity has a particularity that is not, it's really difficult to address physical parameters, for example. And so how positioning or communication, you can address time parameters, you can address some distances. So it's, you can address physical parameters to include it in the overall scenario-based methodology, and cybersecurity has not direct connection to that. So it's a bit difficult to find in this way parameters for cybersecurity, and is more than addressed to how to implement different test procedures on the while using these parameters verification, more kind of a Boolean parameter where you can include such kind of test. But of course, it's an adaptation and has really differences between the other key-enabled technologies. Then we can as well maybe go to the next question, why cybersecurity has a different approach. Well, the main concern of cybersecurity is compared to the other key-enabled technologies is that it's not really connected to a functionality itself. So of course there are at the end functionalities that has to protect, but for example, if we are analyzing the entire vehicle with positioner and communication, address functionality, add the functionality on the car. So positioner can you know the location in a better way, or communication can add a lot of features on the vehicle itself. But cybersecurity has no intrinsic functionalities. So in this case, has and so how to be seen in another perspective. Like we have to guarantee that the functionalities are secure. So there are no vulnerabilities, and they are not vulnerable to attacks. So it's why it's not just to test that the functionality itself is secure, it as well cover the entire life cycle, how Jaco said on the slide of cybersecurity. So in the concept phase, the production phase, all the steps that you're doing to guarantee that cybersecurity is full cover. And I think that you cannot ignore such steps that are important. Once an attack happens, you have to know your vulnerability assessment, you have to know your impact analysis, you have to know your threat analysis, and you have to be able to really fast analyze your system and see where it comes attack from and which are the vulnerabilities. And these are activities that are not well fitted in this enhancement, in this key-enabled technologies parameter here in the scenario. And it's why it has a different approach to at the end guarantee or to cover the entire life cycle of the vehicle. And as well, I make profit to as well answer the last question, which scenarios we use to test cybersecurity. So that's always connected to the assets, and in this case, we strongly focus on the key-enabled technology itself. So for us, it will be really important to cover cybersecurity within the scenarios that are specific for positioning and communications, and that would be our assets. That will be the ones that we focus on cybersecurity, and that would be such scenarios that we are going to focus on.
Okay, thank you for that explanation. I think the first question was also already answered. And then there is a question related to the absolute positioning.
So I will take this one. So basically, absolute positioning was using the CARA word for satellite navigation. But now that advanced autonomous driving systems are coming, we need a deeper knowledge of what is happening around, especially the geolocalization of the obstacles in front of us will become more and more important. As an example, we see that V2X communication will rely on absolute positioning of different vehicles, but in principle, you can also refer the ego vehicle position with other obstacles like the traffic lights or any other obstacle that cannot be sensed by direct sensors. Another important feature is the map matching, because it's very important that most advanced driving system can detect where they can go as a escape maneuver in case of danger or dangers. Okay, I think that's answered the question.
Okay, thank you. Then I think we can end this Q&A part.
Yes, thank you very much, Jaco. Thank you very much, Joaquim. Thank you very much, Andrea. Okay, we are in time. Now we had a break plan. So yes, for the next 10 minutes, we have a small break. We're looking forward to have you in 10 minutes. And on the meanwhile, we will put also some videos, some information on the screen. So if you're interested, also have a look. One last comment from my side before we start this break. For those of you that are not used or have not used, I would strongly recommend you to use the Slido, because this makes it much more interesting. Okay, please ask your questions to us. And that's from my side. We will restart in 10 minutes. You will see now a counter. So back in at 4:45. Thank you all. Thank you very much. We continue in a second. Hello, everyone. Welcome back. And we are ready to start our second part of today's HEADSTART midterm event. For those that have you been here, we will now move on more on the procedures following the methodology that has been explained, also with the key enabling technologies more in detail. Just to, Bernard is our next speaker. Thank you very much, Bernard. Just to remind you, if you want to use, you can use the Slido and send us your questions. Then, with nothing else to be said, thank you very much, Bernard, for your presentation. The floor is yours.
Good afternoon. My name is Bernard Wilpon from Virtual Vehicle, and I will present you an overview of the HEADSTART procedure. So next slide, please. Just as a reminder, this webinar will be recorded and then published on the HEADSTART website. And please, if you have some questions, go to the Slido page, and then please, next page. Okay, the approach of our work was that the methodology that Nicolas already introduced was transformed into a process. The process is divided into further sub-steps, which each addresses a different task that needs to be executed to go through the process and to get to the result whether driving functional test fulfills all the defined requirements or not. After that, we transformed the process into a procedure. We were following the definitions described above. A process is about what to do, and a procedure is about how to do it. So this provides instructions on how the process and its tasks should be executed. Next, please. Here you can see the high-level representation of the process. It is divided into different phases, each of which has the main responsible person. This person can be a company or organization, but also a concrete person. As soon as this person changes, a new phase begins. The phases are scenario selection, scenario allocation, testing method coordination, then the 4 testing methods: field testing, virtual testing, X-in-the-loop testing, and proving ground testing, and also cybersecurity and evaluation. The procedure, like the methodology, is something that can and will change and refine in the course of the project. This presentation shows the current status. Next, please. So the first phase is scenario selection. The necessary input for this phase is a concrete description of the capabilities of the driving function, which should be safety validated in this process. This includes the dynamic driving tasks, the ODD that defines under which circumstances the automated vehicle can execute the DDT, and at the same time also defines the limit of operation for the function. In the first process step, a query has to be created using the information from the DDT, the ODD, and the use case. The query is passed to the scenario database, and the database selects the relevant data and converts it to the requested output format. Currently, Open Scenario is the most promising data format, and it is expected that scenario databases will use this or some further development branch of the specification. So the selected scenarios are then made available in a data bundle, including open scenario files, open drive file, and ideally also a file with parameter distributions. Next, it has to be checked if the chosen scenarios are inside of the ODD, and if the scenarios from the database already cover a significantly large part of the ODD and test already all relevant functionalities to ensure a sufficient safety evaluation of the driving function. If this is not the case, more scenarios need to be added. To have enough coverage to form a safety case for the driving function, it is important to evaluate one scenario description with as many different parameter combinations as feasible. But this means that the effort of the tests increases, and therefore it's necessary to evaluate the importance of individual parameters. And to be able to vary and combine the relevant parameters in a meaningful way, the corresponding parameter distribution is required. Otherwise, it's not possible to make a distinction between scenarios which are unlikely, but probably lead to an uncovering of unknown situations, and typical traffic scenarios which occur relatively often. So ideally, this information is provided by the database. If this is not the case, the distribution must be defined manually by experts. And finally, a few feasibility checks needs to be executed. The next slide, please. The next phase is scenario. One slide back, please. The next phase is scenario allocation. Here, the scenarios will be allocated to the testing methods. But before this can be done, the capabilities of the testing methods for virtual testing, extended loop testing, and proving ground testing have to be specified regarding the sensors or sensor models, the environment or the environment models, and the vehicle or the vehicle dynamic models. This information can then be combined to a so-called map of capabilities. The allocation phase has then 3 different branches. The first one allocates the scenarios from the database to 1, 2, or 3 of the testing methods. For this purpose, the requirements of the scenarios are compared with the capabilities of the testing methods. In this way, it can be determined which testing methods are suitable for each of the scenarios. The final decision, if all possible testing methods will be used or just some of them, will be made by the target group. The second branch is a very CAD-specific one, and with CADs, in this case, I mean communication and positioning. So this branch is optional and will only be executed if the scenarios from the database should be enriched by communication or positioning related parameters. Here, a logical layer for communication or positioning with additional parameter distributions will be produced. And with this information, an allocation to real-world testing methods or virtual testing methods will be made. There is also an optional third branch in the phase, which is used if there are other requirements that have to be tested that are not covered by scenarios from the database and are not communication or positioning specific. This is necessary because process is defined in such a way that it is not limited to the needs of the project, and therefore this third branch is very general to cover all the requirements that were not covered by the other branches. Next, please. The next phase is testing method coordination, and it consists only of one task. So the target group has to decide in which order the testing methods should be executed. It's possible to choose a specific testing method first, or it can be decided to run the tests in parallel. For example, it's possible to start with virtual testing only because it's less expensive and more scenarios can be executed. And then after successful execution, go to the proving ground. So this step provides the necessary flexibility in the execution of the test. Next, please. So now to the testing methods. So for field testing has a special position among the testing methods because it's not possible to reproduce scenarios from the database exactly in the field test. However, certain requirements that are independent of specific actions of other road users can be tested. For this purpose, A route has to be found that fulfills the criteria of the scenario and on which it is authorized to carry out such tests. The tests on open road need to be planned in an appropriate way because depending on the country where the vehicle will be deployed, there will be different regulations that need to be fulfilled in order to conduct tests on the defined routes. So first, a field testing strategy has to be defined. This contains information about the vehicle and the test setup, so the equipment that needs to be installed, like data logging systems, reference sensors, context cameras. Then driving function dependencies like other controlled target vehicles or the existence of HD map services for accurate localization has to be defined. Information about the infrastructure requirements are also needed, like the availability of communication base stations, differential global positioning system services, or information about regulations and exemptions. And with this information, the vehicle and infrastructure equipment can be prepared and the tests can be conducted. The log data is then stored and can be used to evaluate the tests. Next, please. The second testing method here is virtual testing. Here also strategy has to be defined, how the tests are performed and what's needed in terms of hardware and software resources and interfaces. It includes how to validate each model and simulation component, and it should identify the mechanism to declare allocated test cases as ready for testing. Before any test can be conducted, it is necessary to validate that the required components are available or compatible with the simulation framework. When all models have been coupled, the simulation can be carried out and the simulation is executed, recorded, and stored in an appropriate format. Next, please. The next phase is X-in-the-loop testing, and this is in many ways very similar of that of virtual testing. So the essential difference is that there are real elements that are used in the test. So therefore, logistic aspects need to be taken into consideration. In particular, the strategy has to address the schedule to run the tests in the appropriate time frame because of the real components, and these components limit the ability to parallelize the test. For the preparation and the execution of the X-in-the-loop tests, the same things as for the virtual test have to be considered, plus the required steps regarding the management of the real components. Next, please. The last testing method presented here is the proving ground testing. In contrast to the field testing, there is no need to select a track. The proving ground itself was already defined in the scenario allocation part, and based on its capabilities, the scenario were assigned to the testing method. So it is sure that every scenario that was allocated to the proving ground can be executed. The first step is to set up a plan on how to execute the tests in the most cost and time efficient manner. Test plan has to include the vehicle and the test equipment, the infrastructure equipment like targets, communication infrastructure, digital maps, and the test cases with the acceptance criteria. Before the test can be executed, it must be ensured that the equipment is prepared, that the vehicle and the infrastructure and the test driver, of course, are ready for the tests. And after the test data has to be saved for further processing. Next, please. So cybersecurity is, of course, a key enabling technology in HEADSTART, but it's also a key area outside of the project. So therefore, it's important that it has a position within the process. In contrast to the other CADs in HEADSTART, it was not possible to integrate cybersecurity completely into the existing structure of the process. Therefore, there is a separate cybersecurity branch which is connected to the main process. But the cybersecurity part is kept such that the execution of the process steps is optional. So the cybersecurity part of the process is based on common criteria activities. The first activity is to select the selection of the protection profiles. It identifies generic security requirements for a group of security devices relevant to the user for a particular purpose. The second activity is the definition of the target of evaluation. It defines the item or system of evaluation for the process. The next step is the generation of specific security needs for the target of evaluation, what is called in the common criteria the security target. Next, it is determined which requirements are available for allocation in the main process. So this step connects the cybersecurity testing activities with the differing testing methods, and the results of the test will be collected at the end of the process and integrated into the security target. And the final steps of the cybersecurity branch are connected to independent testing lab activities. So in the end, the results of these testing laboratories together with the security target report are grouped together for the final report. Next, please. The last phase of the process is evaluation. So this phase consists of two parts. At the beginning of the process, the key performance indicators have to be defined. And when it has to be, then it has to be defined how these key performance indicators are verified. So this part influences many other process steps of the process from scenario selection to the actual test. The second part of the phase begins after the tests have been performed. So the relevant test data is extracted and compared with the KPI criteria. Compilation of test results is needed to determine if the KPIs have been met for the function. So the compilation includes results from the four testing, safety testing methods and the cybersecurity results. And a summary with statistics on coverage and passed or failed evaluation criteria should be included, and any failed criteria should be highlighted. A comprehensive report should then be compiled. It should include a description of the testing methods and the test object, and the results presented in the report will be a summary of the recorded test data. So a statement on fulfillment of a KPI must also be accompanied by an explanation of why the KPI can be judged as fulfilled. So this is the end of my presentation, and I hope I gave you a good overview of the HEADSTART procedure. And I think we can then switch to the questions, if there are any. Yes. The first question is, does the procedure change for different target groups? So in HEADSTART, as Alvaro already mentioned in the beginning of the presentation, we have different target groups: development, consumer testing, and type approval. The tasks in the current process do not change from one target group to another, but there are several places where they can influence the further process. So for example, the actual allocation of the concrete scenarios to testing methods is a process highly influenced by the executing target group. They can determine where the focus is set and in which order the test should be executed. And the target group has also a role in the cybersecurity branch and, for example, also in defining the KPIs. Then why is cybersecurity an own phase and positioning V2X communication not? So the focus of the HEADSTART project, of course, the key enabling technologies are on V2X communication, positioning, and cybersecurity equally. But it was not possible to use the same process steps for all three of the CADs. So they had to be dealt with differently. Communication and positioning could be integrated into the main process most of the time. In the scenario allocation phase, as I said, there's a separate branch for communication and positioning. There it was not possible to integrate it fully into the main process, but most of the times it could be integrated into the main process. Cybersecurity, on the other hand, has different requirements and a completely different testing structure, and therefore a separate phase was created to cover the needs of this CAD. The third question, in the beginning you're talking about scenarios, and in the later stage about test cases. What is the difference? Is this relevant for this procedure? Yes, there is a difference, because in the beginning you're talking about scenarios. These are the scenarios that we get from the database that are usually in, for example, open scenario format. But especially when we go to proving ground tests or field tests, those scenarios alone are not enough. So when we talk about test cases, the scenarios are a part of the test cases, but for example, also the so KPI criteria, criteria when the tests are, if the criteria for when we can say that the test is conducted successfully is also part of the test case. So scenarios are a part of the test case. So if there are no other questions, I will hand over to the next presenter. And thank you.
Yes, thank you. So my name is Chef Montfort from TNO, and I would like to tell you a bit more about the use cases that we use within HEADSTART and what their role is. Next slide, please. Yeah, so first a short reminder of the rules and the processes. So the webinar will be recorded and the slides are being shared together with the recordings. And questions, please put them via Slido and hashtag HEADSTART. And please do not use the GoToChat. Next slide, please. I still have two. So yeah, in work package 1, we made an overview of different use cases that are available and how they could work together with HEADSTART. Where in HEADSTART, as shown before, we have 3 CADs, so key enabling technologies. So we looked into to what extent could those use cases cover those CADs. So the different CADs, positioning, communication, V2X, and cybersecurity. We also looked into how well are they able to be represented with the 4 different testing methods that were also mentioned before. So the physical testing, or the field testing, proving ground testing, Excel-based and virtual testing. Then we also wanted, because it's a scenario-based approach, to what extent are there scenario databases available and how well could they be linked? That's another criteria that we looked at. Also, because in the project itself, we do not develop the functions or vehicles ourselves. So we need to look for collaboration partners. So to what extent will they be available for each of the use cases? And then last but not least, we looked at the relevance for the 3 different key user groups that we defined. They were also mentioned before. So the OEMs and tier 1s, the type approval authorities, and consumer organization like Euro NCAP. At that time, we had 5 different use cases selected with all a certain priority. And that was like about 1 year ago. If you can go to the next slide. So in the end, the middle of this year, we selected 3 to really go with further and to further detail them. We had the truck platooning, the highway pilot, and the traffic jam chauffeur. This was also based on some developments that we saw in the field. For example, one that was very relevant and interesting for us was the new UNECE regulation that is coming into play, that is very much related to traffic jam chauffeur, which was one of the reasons to put that actually further up our list and also select that. So with those 3 use cases, we believe that we can cover and we can demonstrate the HEADSTART methodology. I will now tell you a bit about each of them and then later on how they can work with the HEADSTART methodology. The next slide, please. So first about truck platooning. How do we see truck platooning? In HEADSTART, we say like, let's keep it relatively simple. So it are 2 or more cooperative trucks driving together in a line that maintain a close distance enabled by vehicle-to-vehicle communication. Especially this last bit is very relevant because it very well enables us to demonstrate and to evaluate the communication key enabling technology. Of course, also positioning is a relevant key enabling technology, and also cybersecurity, of course, because the communication is such an important thing. And already mentioned in one of the previous presentations, they are very linked together. Then looking at the stakeholders, so the key user groups, this truck platooning is very relevant for the OEMs and tier 1s, and for type approval authorities. At the moment, it's less of interest for consumer organizations because in general, the consumer organizations do not consider truck platooning and commercial vehicles in much extent. Next slide, please. So then to even narrow it further down, also to keep it simple and actually also to make it easier linking to one of our, we call it link projects, I'll tell you a bit more about that, is we did define it even further, the automation level, because it's very close to real life implementation. So where the first truck is manually driven, it can be supported by ADAS systems, but in basis it's manually driven. And the following trucks have full automated longitudinal control, where the driver, safety driver, still is responsible to keep it in lane. This is used as a basis for our assessment and for our evaluation, but of course we keep an outlook to higher levels of automation because we are aware that that will be the next steps. And then the next slide, please. Then another HEADSTART use case is traffic jam chauffeur, where we look into, at the moment, like conditional driving automation, so at a level 3, in traffic jam conditions. So on a highway and other structurally separated roads, so that's an additional restriction with a speed of 0 to 60 kilometers an hour. This again also to limit the complexity, but also it's not essential that it's more complex to demonstrate the methodology. Looking at which the relevance of the CATs, again, all 3 of the CATs are of relevance. However, you could argue for a traffic jam chauffeur, is communication V2X really essential? perhaps not necessarily. So we'll see if we can demonstrate in this use case also this component. Then looking at the key stakeholders, so the key user groups. Here, type approval is very relevant, as mentioned, especially with an eye to the new UNECE regulation, but also consumer organization, because this is a lot related to passenger cars, and of course the OEMs and tier 1s and tier 2s. Next slide, please. Thank you. So then also to condense it even more, to keep it in that sense a simple use case, is we put in some additional restrictions. So to say the traffic jam chauffeur is capable of keeping the vehicle in the current lane and to keep the distance. So the whole lane changing, we excluded that to keep it simple. The simple activation situation, also takeover requests, we already defined it in a certain sense to make sure that it's not too complex. And also our takeover, we set some requirements on that. But again, similar to the previous one, we use this as a basis for the discussion and for the evaluation, but of course we keep an eye on the higher level of automations. I also already mentioned this one has a especially strong link to the UN regulation on automated lane keeping systems, and with that, of course, also to type approval. So this is a very nice use case where we can very strongly link to that user group. Next slide, please. Then the last use case that we will use is the highway pilot. This looks in a way similar to the traffic jam chauffeur. However, this is also already looking a bit higher level automation. So we'll also look at the SAE level 4, so the highly automated driving on highways, so between entry and exit. And this has a higher speed range, where in principle we will not look at start-stop kind of situations, but indeed it's up to, well, in many countries, the maximum allowable speed limit of 130 kilometers an hour. In this, there is also the cats represented, but you can imagine that for these systems, it might be more interesting to also have the communication component, for example, to get information on the speed limits, but also on other roads, construction works, for example, and other topics like that. Positioning and of course cybersecurity are also relevant features of those systems. Then looking again at the user groups that are exactly the same, so OEMs, type approval, and consumer organizations. If you go to the next slide. Yeah, so indeed to limit that also, again there we will limit it a bit, the scope that we look at, so by reducing the ODD, because in theory highway pilot could cover all driving on the highways, even if you would consider German highways, it would be an infinite speed almost. So to limit that, we have put in some restrictions. One of the interesting questions that we are now looking at is what is the exact ODD that we will look at for a highway pilot? For example, what kind of environmental conditions will the ODD cover? So what the thresholds, for example, for visible conditions, but also other weather conditions. Even the static scenery can change quite a bit. What do you do despite that it's highway? A highway in Europe looks different than a highway in the USA or in Canada. But also the highway is quite well defined and quite empty, except, for example, if you also take into account toll gates, then it gets a lot less defined and a lot less easy. So should we cover those or not? And also include some more challenging sceneries, like, for example, the inclusion of pedestrians. Should we consider that, yes or no? Next slide, please. So then about really what is the role of HEADSTART use cases. So indeed, as mentioned, the idea is to use the use cases to demonstrate the HEADSTART methodology. And for that, we want the different use cases that I just described to find, we call them linked projects, because as mentioned in HEADSTART itself, we do not develop the systems ourselves. So we will have to closely work together with so-called linked projects that will enable us to demonstrate the HEADSTART methodology. Those linked projects, they include Ensemble, the big European project on multi-brand truck platooning, the MUCA project from the UK, supported by IDIADA, the CAF-RIDE vehicle from IDIADA, and the automated drive demonstrator by Virtual Vehicle. Later on, I'll show you a bit more about those. But what's good to keep in mind is that the focus is really on demonstrating the HEADSTART methodology. And it's not to demonstrate how well the vehicle or function performs. And I think it's also good to keep in mind. So it could be that despite the limited functionality, it is still possible to demonstrate the HEADSTART methodology. So the next slide, please. So what are important aspects to be covered when we want to demonstrate the HEADSTART methodology? Earlier on, this was also already mentioned, also in the different presentations before. On the right-hand side, you see a schematic picture of the methodology, where there are several important steps that will be covered by demonstrating it. So the scenario-based approach, that's a very essential part of our methodology. So it's very important that the use cases and the linked projects allow us to demonstrate that you can work from a scenario database with selection and allocation of scenarios towards the different testing methods that are part of our methodology. So the field testing, virtual testing, skill-based testing, and proving ground testing. They all can play their own role within the assessment. Also, what we want to do is demonstrate that the HEADSTART CADs can be part of this assessment, because they are an important component of the vehicles and of allowing and enabling actually the CCAM in the future. And then, of course, we want to demonstrate that the methodology that we defined can be used and is relevant for the different user groups, so the OEMs tier 1s, type approval authorities, and consumer organizations. What's also good to keep in mind is that the current linked projects are probably, but that's not a surprise, not able to cover all the aspects that are mentioned above at the same time, so by itself. Just to name one, indeed, the truck platooning, as mentioned, it will not be able to cover the key user group, consumer organizations, in a very good sense. But the idea is that all linked projects together will be able to demonstrate the feasibility of the topics I mentioned above. So the scenario-based approach, the testing methods, and the HEADSTART CADs, and they demonstrate the relevance for the different user groups. So by combining the different linked projects, we will be able to do this. Next slide, please. So then I put some information of different linked projects in. So here you can see the Ensemble one. So this is really about the driving function based on truck platooning, where positioning and communication are a very important component. Those are already defined some test cases where field testing, skill-based testing, and proving ground testing are a part of Ensemble, with field testing and proving ground testing scheduled for next year, and skill-based testing that is already being performed. Virtual testing, it's not a part of Ensemble, but we're looking into a direct connection with the OEMs to see if we can somehow include this when demonstrating the HEADSTART methodology. The same holds for the database. There is a database in a sense that there are test cases defined with scenarios, but it's not like a recorded database as described before. So that's also a component that we will evaluate to see how can we demonstrate this within the context of Ensemble. Also, cybersecurity is something that is being investigated. Can we use the Ensemble project to evaluate cybersecurity? This is also related to how it is implemented in Ensemble. If in Ensemble it is not covered in a certain way, then of course we can also only assess this to a certain extent. Next slide, please. Then looking into the automated driving demonstrator from virtual vehicle. So there it's the driving function is really looking into the highway pilot and traffic jam chauffeur use case. There we can more have it from an approach where via the query, we look into the database and we define test cases, ideally via the standards open drive and open scenario. And then look at the different types of test methods to cover the different component or the different ways and the different inputs that are needed. So we have field testing, where there's actually also virtual testing with a cross-validation. So actually what was recorded in field testing can be virtually tested. There are field-based testing possibilities, for example, the driving simulator that is available, and it's possible to do some proving ground testing. In the next clip, you can see some of those testing methods. Next slide, please.
Yes, stop.
Yeah, so thank you. Yeah, so what's good to keep in mind is that this was just to demonstrate some of the testing methods. It was not yet about demonstrating the specific use cases, but indeed the idea is to in the next year to use really and apply the use cases and demonstrate the specific topics that are related to the use cases. So this is the next link project. Well, actually, it are two link projects. I combined them because both are supported by IDIADA. So the MUCA and the CAF ride. They also have similar features. On the other hand, they have also their unique features, but they both focus on highway pilot and traffic jam chauffeur, with the possibility to evaluate possibly the 3 different CADs, depending a bit on the exact implementation. But here again, we would like to go via the database, again, to select the scenarios that are relevant for the different use cases, and then based on the use case, to see which of the test cases are applicable to which of the different testing methods, and then by combining the different testing methods to get a full assessment. And here you can see at the bottom some pictures of, for example, on the bottom right, and the second from right are two of Muka, where there is one which is actually on the test track with two vehicles that are driving together and communicating how they should avoid an object. And the one next to it is actually where there are even multiple vehicles with communication units talking to each other. And then, of course, we have the virtual testing and the field testing. In the next clip, there is also, again, something about, this is the CAF ride demonstrating, also about the feasibility of testing that is possible with this.
Covers the current gap between simulation and physical test methodologies by integrating a real vehicle into a virtual traffic environment. Thanks to our expertise in advanced simulation tools, we have designed a new virtual testing platform to support the development of ADAS and automated driving. By applying IDIADA's methodology, information from virtual sensors is injected into the vehicle's ECU to test the vehicle's behavior when triggering the physical actuators. The geolocalization of the vehicle allows us to merge virtual and physical worlds, providing immersive scenarios to the driver. The main applications of vehicle-in-the-loop are the pre-calibration and evaluation of ADAS and automated driving systems. It is also being assessed by Euro NCAP to be included in the vehicle safety rating process, allowing a wider test matrix coverage. Through specialized simulation software, our engineers can generate a wider range of complex traffic scenarios according to existing and future standards, guaranteeing the driver's safety. Our vehicle-in-the-loop testing is a cost-effective solution that allows ADAS and automated driving systems development and validation in multiple complex scenarios with a high degree of accuracy and repetitiveness. IDIADA has all the necessary know-how and tools to perform vehicle-in-the-loop turnkey programs. Our versatile and modular virtual platform is a tailored solution that adapts to our clients' requirements.
So yeah, thank you also IDIADA and VIV for Virtual Vehicle for providing the information. Also here, please keep in mind that the actual development of the system and the functionality is done outside of the HEADSTART project by IDIADA. The only thing is that we use the system and part of the testing that was already done to show and demonstrate the methodology. Next slide, please, because I think that's also the last one. Yeah. So actually, to summarize indeed, we will use different use cases, the 3 different use cases: truck platooning, traffic jam chauffeur, and highway pilot, where we do that via linked projects that can cover the different aspects to demonstrate the HEADSTART methodology. I think now we can go to the questions. Thank you. So question number 1, and thank you for the questions. Why 2 different use cases for highway pilot and traffic jam chauffeur? Indeed, you could argue that traffic jam chauffeur is a component of highway pilot. We have, however, chosen to split it, partly because traffic jam chauffeur very well matches the UNECE regulation. So by defining it as a separate use case, we believe that we can more easily cover that component or that section actually of the methodology. On the other hand, highway pilot, if we then put it a bit away from the low speed, we can more easily encounter and we can include more easily, especially topics like the communication component. So that was the reason why to split them. I hope that answers the question. And then the second question, do current or available databases include all the required parameters for testing the HEADSTART cats? No, and unfortunately not. On the other hand, I think that's something that's definitely also in the earlier work packages mentioned. This is something that the current databases lack, but I think that's a good thing in the sense that we now clearly can demonstrate that it is needed. So what will probably happen is that we will extract the scenarios or the test cases from the databases, and then we add, where needed, can add the parameters that cover the HEADSTART cats. But of course, this is a more or less a temporary solution, because ultimately, I think a database should also include also all the required parameters. So also for the specific HEADSTART cats that we now that we have defined and that might be missing at the moment. But if we can provide feedback, and that's what we will do from the project, if we can inform or let the databases know what kind of information additionally needs to be stored to also cover those HEADSTART cats, I think that's an additional output of HEADSTART that it can very well contribute to the overall methodology. If that are all the questions, then I would like to thank you for your attention. And I think then we can go to the next speaker. Alvaro, is it you? Oh. Are you the next speaker, Alvaro? We
no,
can't
it's a
hear
Stefan.
you.
It's a Stefan.
Oh, sorry.
Very much, yeah.
Ah, sorry.
Okay, so good afternoon. So after having heard all these different presentations about the nice things we are developing in HEADSTART, you might wonder how you can get involved and help us by contributing to these developments. And so we have a specific objective within HEADSTART to do that. So in the next slide, you can see that among the objectives that Alvaro already presented at the beginning of this presentation, we have one about the validation of safety and security performance according to the needs of key user groups. And these key user groups include technology developers, consumer testing, type approval, but also any other relevant stakeholder. So more precisely, we have this objective 5, which is about reaching consensus. And the objective here is to involve the testing and validation expert community to steer and validate in an iterative way the project progress. And to achieve this, we have created the HEADSTART expert network in order to really ensure the appropriate engagement of all the stakeholders. So the stakeholders can be, of course, members of the consortium, but even beyond all external partners, and that they contribute to the HEADSTART developments. The next slides. So we have a specific work package that has developed and is maintaining the expert network and is also in charge of international cooperation. The expert network is really the platform used to engage the testing and validation expert community in testing and steering the HEADSTART progress. It serves as a purpose to align and build consensus in all the developments. And the objective is, of course, then in the end, to maximize the impact that the project has. The network can consist of 3 different types of stakeholders. So first, it can be experts who generally provide the expertise at the technical or strategic level on issues such as positioning, communication, scenario selection, and cybersecurity. It can be other related projects with which HEADSTART can establish synergies, exchange relevant results. Of course, we speak here about public results or publishable results. in order to align as well the results from HEADSTART. And it can be as well non-European or international cooperation initiatives which the project has established communication with or is involved in through its consortium members. On the next slide, we have therefore set up 6 different working groups. The 3 first ones are related to the key enabling technologies. As you have heard, the key enabling technologies are a very important component in HEADSTART. These 3 working groups are separate or involve different experts, but sometimes we have organized combined workshops depending on the topics we want to address. But the main purpose here is to validate and enhance the evaluation methods and procedures based on the experience and lessons learned and feedback from the experts on these key enabling technologies, and make sure that the testing methodology as well include these the requirements in the best way. The focus is on evaluation, but looking towards a common methodology and procedures that could be used for certification. Then we have 3 other working groups. So one on scenario selection. So this working group ensures relevance and accepted logical scenario concepts in the validation methodology. And here we are looking in particular into having a complete scenario parameter descriptions. Another working group is the consumer testing. So this working group interacts with Euro NCAP stakeholders as the end user to support them from the technical point of view in their safety assessment efforts, and make sure that as well the HEADSTART methodology and its associated procedures are compatible with the Euro NCAP testing methods and needs. Then the last group is a type approval, where we want to consider the constraints and advantages of type approval for the development of test methods, and check how the intermediate outcome on scenarios and simulations and real-world testing will affect the work of the type approval. On the next slide, we have as well a project-to-project cooperation. So for that, we have identified different levels of cooperation. So we have already started consultation with many projects, but of course are always open to discuss this further in order to align with any other initiatives that is out there. We have this cooperation can be mainly only an information sharing or cross invitation to different webinars and events. The next step would be then the organization of joint webinars or dissemination events, or even contributing to joint deliverables and reviews or contributions. And then the last level is really then to have a distribution of results data, organizing together research activities or joint testing activities. And we are of course open to consider any other type of cooperation. After that, I also mentioned on the next slide, there's also the international cooperation. But there it's okay, it's really open, similar to project cooperation, but at an international level. So more concretely, how can you cooperate with us? So here you have the different possibilities. You can either join as an associated partner, and then you will be able to select which working group or your expert group you want to participate. I mentioned already the 6 working groups. And then you will be invited to provide needs and requirements and evaluate the project's intermediate results. There's also the possibility, as I mentioned, to participate in joint testing actions. It's a joint cooperation, align our different projects. But in any case, please, you can contact us directly. There is either through the email address provided here at info@headstartproject.eu, or you can visit the website where you have all the information as well of what is the benefits of joining as an associated partner. I think the last slide is just summarizing the different ways of contacting us. I think that will be repeated as well at the end of this webinar. And that concludes my part. Thank you.
Thank you very much, Stefan. And now is when I connect. Sorry for that. My bad. Thank you very much. Well, we are at the beginning of our last presentation of today. And here, Carlos, could you move one slide, please? Yeah, here what we would like to introduce to you is what is coming on, okay? So what are the next steps? What are we going to do in this 1.5 years that we have left with us? So first of all, I would like to come back to this slide that has been used during the presentation several times. And Carlos, one click, please. This is where we are. Okay, so today we show you the previous steps that we took in terms of identifying what was out there, harmonization. What we have left for the rest of the project is start the implementation of the testing toolchain and demonstrate the methodology of HEADSTART through these 3 use cases that we've chosen. And of course, we'll have a rich consensus. Next slide, please. So to give you an idea, today we show the methodology, which was a result of our work package 2. We saw the procedure, which was the first result we have from our work package 3 within the project. And what we have left is the next. Click, please, Carlos. So we have now this. We are going to focus more on what would be this development of the tool chain of the different elements. And next slide, please. First steps. We are now in this process, actively working. It's the development of this test environment, specification, and associated tools. We've seen already today, we are going to include virtual and physical testing within this procedure. It's part of the activities right now is to develop tools that are needed or adapt or enhance existing tools that are already in the market or that are already being used in the connected automated driving arena. We are also going to start working directly hand with the databases to query and use their scenarios. We already saw this was part of the methodology in the procedure. And once again, and this is very important for us, taking into account what would be the needs of the target user group. So developers, consumer testing, and type approval. If we move to the next slide, please. Carlos, can we move to the next slide? Yes, sorry, thank you. Nope, previous one. Sorry for that, a little bit of delay. Another important thing that we are going to work during this following month is the definition of what will be the assessment criteria. And here we are going to work on the definition of these indicators that will be used for the assessment of the CAD functionalities regarding its safe operation and with the use cases we saw today. This is also going to be extended to the key enabling technologies, so communications, positioning, and cybersecurity. And we will also take into account what would be important KPIs that will be needed for the target user groups. Next slide, please. And finally, not finally, another important stage that we need to take into account is how are we going to manage all the test data and how to harmonize this test data that we are going to use or we are going to create. So we will work also in the definition of annotation model concepts, tool development for the outputs, storage, streaming, query, all the different information that are related to the management, creation and management of test data. And of course, take into account to integrate it in the whole process. Next slide. And finally, and before moving to the demonstrator, we will put together all this, everything that we have worked in the, not just in the testing toolchain, but also the methodology. We put this together for the defined use cases. So we will go over them one by one. You already seen some of the things that we are going to do in order to prepare them for the demonstration stages, which is what will be the next thing to come. Next slide, click please. Ooh, we got delay here. Or I got delay. So next one, Carlos. And next one. Yes, we get to the demonstration. So this is also where we get to the real world. So here is where we will apply the development method, the development procedures to the selected use cases. And we will apply them both in virtual and physical testing. choosing a number of scenarios from the different databases, using the different test methods. And as Jeff was saying in his presentation, with this idea, we can check all the different needs from the KED point of view, from the target group point of view, in order to be able to demonstrate the methodology. In the next slide, please. Of course, we have also to work on the assessment of test results. So we are working also on the evaluation of the method, practitioner, and tools in terms of scalability, robustness, reproducibility. At the end of the day, we're going to test these use cases. We're going to assess these use cases, and we're going to deliver the results of the testing. And this test will be in the next slide, where we go to the demonstration itself. So during the second half of next year, 2021, stay tuned with us. We will organize a number of demo days to show the community what are the project results and how to give you this touch and feel of look and feel of what we have developed within the project. Of course, and according to our intentions, this at least one of them should be an open public demonstration. But right now, I'm sorry to say, but I cannot guarantee this at this stage, as you can imagine, because of the circumstances that surround us. And we will have the final event of the project, which will be, yes, at the last months of 2021. So a lot of exciting things to come. So we are going to implement our testing tool chain. We're going to test our use cases with its linked projects behind, and it's going to be done in a way that it can be shown to the community how we have reached this and how is it working. Next slide, please. And yes, to finalize, it's only 7 minutes until the end of the project. Just wanted to give you a small wrap up of what has been today midterm event. I would like also to, yeah, please next slide. And next slide, because we already know this the slide for present. We have seen an overview of the state of the art. So what are the different initiatives on validation regarding to connected automated driving? This, as we said, was the basis also to define the HEADSTART methodology, to understand all the different initiatives that are going there in the world, how we can harmonize this. And again, and as Nicolas said, harmonization is very important for us. And in this context, we're making a special effort on communications, positioning, and cybersecurity. And so we presented you also how we are approaching these key enabling technologies for connected automated driving. Next slide, please. We also saw that it's not just the methodology that you need to evolve, and this is where the procedure jumps in. So this methodology, this procedure that was presented by Bernard from Virtual Vehicle, it is the basis of their current work and our future work. Is where what we will look after when developing and testing tool chain. And this will be applied with the HEADSTART use cases, which were also shown to you and presented. Highway chauffeur, traffic jam chauffeur, and truck platooning. This is very important because at the end of the day, we will demonstrate validate the validation methodology that we have developed within HEADSTART, and this will be done in the process of the next months. And last but not forget, this is a living project, and we want to be in touch with you. And this is where the expert network jumps in. So please, if you want to know more, contact us, join our expert network, follow us on our social media, be updated of all the different events we have. For the next months, we will organize also, we would have preferred physical meetings, physical workshops, but we will have, within our hands, the organization of different dedicated workshops for the different topics that are important we understand are important for the stakeholder community and for the project itself. And next slide, please. And just to give you an overview, this is the current list of deliverables that have been finished by the project. All that you have seen today, it's reflected in these deliverables, which you may find if you go to our webpage, so headstartproject.eu. There you can have, as I said, all the information, you can join the expert network, you can download these deliverables for your users, and of course, you can contact us. So next slide, please. more information, how to reach us, and finally, just wanted to, on behalf of the HEADSTART Consortium, I would really like to thank you for attending today's event. I hope that what we presented today is interesting for you. If you have any questions, if you want to be an active part of what we are doing, please come join us. This was just today a way to show how we are doing. This can be also an active participant of the HEADSTART project. We're really looking forward to cooperate with you. And with this, we have finished the event today. I would really like to thank the people, all the speakers today. In the past, we would have given them an applause. This is a bit weird when you do it on a telco, but from my side, I would really like to thank them for the organization, for the presentations, and for being there for your questions. And that's all. It's 3 minutes to 6. I guess it's been a long day. So from my side, that's it. Thank you again, and we keep in touch.